All right, let's go. Number 10. The absolute speed limit. The universe is not a frontier waiting to be conquered. It is a meticulously engineered cage. We view speed as a temporary engineering hurdle. We design sleeker jets, more efficient thrusters, and nuclear propulsion systems, operating under the arrogant assumption that human ingenuity will eventually outpace the vastness of space. We look at the stars and assume that, given enough time and enough funding, we will eventually sail between them, just as we sailed across the oceans of Earth. The universe operates under an entirely different set of rules. It enforces a strict, unbreakable, mathematical velocity limit, 299,792 kilometers per second. In a total vacuum, a single photon of light can lap the Earth's equator 7.5 times in the span of one single second. In one Earth year, that same photon covers 9.46 trillion kilometers. We call this measurement a light year. We treat it as a unit of distance, a convenient shorthand for astronomers to map the cosmos. It is not just a unit of distance, it is a leash. Consider Proxima Centauri. It is a red dwarf star and the nearest stellar neighbor to our own solar system. It is our immediate cosmic next-door neighbor, located just 4.24 light-years away. In galactic terms, it is practically sharing our orbit. It is so close that its gravitational neighborhood frequently interacts with ours. Now, apply the absolute pinnacle of human engineering to that short distance. The Parker Solar Probe is currently the fastest physical object ever constructed by our species. At its peak velocity, utilizing the gravitational whip of the Sun, it travels at roughly 700,000 kilometers per hour, or roughly 430,000 miles per hour. That is fast enough to fly from New York to Los Angeles in roughly 20 seconds. If we built a gargantuan generation ship, loaded a human crew onto it, and somehow propelled that colossal spacecraft at that exact blistering speed without destroying it, the journey to our very closest neighbor would still take 70,000 years. 70 millennia. Stop and think about the sheer, crushing scale of that timeline. Recorded human history, every empire that has ever risen and fallen, every war ever fought, every technological revolution from the invention of the wheel in Mesopotamia to the splitting of the atom in the 20th century, spans barely 5,000 years. On a ship bound for Proxima Centauri, you would need that entire span of recorded human history to play out 14 consecutive times before you even approach the destination. Generations of human beings would be born, live their entire lives, and die in the artificial hum of a metal corridor. They would never feel the warmth of a real sun. They would forget the concept of a blue sky, of wind, of ocean tides. They would lose the memory of Earth, reducing our entire planet to a mythological story told to children who have never seen dirt. The original crew would be ancient, forgotten ancestors to the people who eventually arrived, and they still wouldn't even be scratching the surface of the galaxy. That 70,000-year timeline isn't a long-haul voyage. It is just the starting line of the cosmic void. Number 9. The night sky is a graveyard. Step outside on a clear, crisp night and look up. You feel an immediate, profound connection to the cosmos. You perceive a vast, static ceiling of brilliant lights shining down on you in real time. You think you are looking at the universe exactly as it exists in this very second. But human biology is easily deceived, and our brains are not wired to comprehend the delay of the cosmos. Light requires time to cross the vacuum of space. The speed of light is fast, but space is so unimaginably vast that light is reduced to an agonizing crawl. When you look at Sirius, the brightest star in the night sky, the stark white light hitting your retina left that star 8.6 years ago. You are not seeing Sirius as it is right now. You are seeing a photograph of Sirius, taken nearly a decade in the past. When you locate Betelgeuse, the titanic red supergiant glowing ominously in the shoulder of the constellation Orion, you are looking at light that has been traveling through freezing, empty, irradiated space for over 6 centuries. You are not observing the universe. You are watching a delayed broadcast. Because of this inescapable delay, many of the immense, beautiful structures currently illuminating our telescopes and enchanting our astronomers no longer exist. Stars run out of nuclear fuel. They reach the end of their lifespans, lose their battle against their own gravity, and detonate in colossal supernovas. They shed their outer layers in violent explosions that outshine entire galaxies, and their cores collapse into incredibly dense neutron stars or black holes. They die. But the news of their violent death has not reached us yet. The light of their violent end is still crawling across the universe, thousands or even millions of years away from our lenses. When astronomers study distant star clusters and majestic nebulas, they are not studying living systems. They are acting as cosmic archaeologists, analyzing phantoms. The universe we see is a projection of a past that has already been entirely erased. There is absolutely no way to calculate exactly how many of the brilliant lights currently burning in our night sky are already dead, leaving us praying to a graveyard of extinguished stars. Number 8. The Oort Cloud Barrier. In the late summer of 1977, humanity launched Voyager 1. It was our greatest and most optimistic endeavor. Its mandate was to photograph the outer gas giants of our solar system and then keep flying, pushing outward into the absolute dark, carrying a golden record encoded with the sounds of Earth. A greeting to the cosmos. It has been traveling continuously, without a single moment of rest, for 47 years. It travels at an astonishing speed of approximately 61,000 kilometers per hour. It crossed the termination shock. It passed the heliopause. It officially broke through the magnetic bubble generated by our sun and entered interstellar space. It is the furthest any human-made artifact has ever gone. Now, do the math on its actual progress against the backdrop of a light year. In nearly half a century of relentless, blistering flight, moving fast enough to cross the entire Earth in a matter of minutes, Voyager 1 has covered a total distance of roughly 22 light hours. Light hours, not years. It hasn't even reached the inner edge of the Oort cloud. The Oort cloud is an immense, theoretical spherical shell of icy debris, comets, and frozen planetary remnants that marks the true, final gravitational boundary of our solar system. It is the parking lot of our sun. Estimates based on gravitational modeling suggest it will take Voyager 1 another 300 years of continuous flight just to reach the very beginning of that vast ice field. It will fly in the pitch black for 3 centuries just to hit the border. To fly completely through the Oort cloud and finally escape the sun's gravitational anchor forever, the probe will need to travel for another 30,000 years. 30,000 years of silent coasting through a freezing minefield of dead ice. Our greatest triumph of exploration, the golden child of human spaceflight, has not even scratched the surface of our own driveway. We celebrate reaching interstellar space, but we are still locked tightly in the basement of our own solar system. Number 7. The communication wall. Driven by the chilling silence of the cosmos, we beam radio signals deep into the dark, desperately hoping to strike up a conversation with another intelligence. We point sprawling, sensitive satellite arrays like the ones at Arecibo and the Very Large Array at distant exoplanets and listen for a whisper, a mathematical pattern, any sign that we are not entirely alone. But the speed of light guarantees that interstellar diplomacy is not just difficult, it is mathematically impossible. The Milky Way galaxy, our home, is approximately 100,000 light-years across. Radio waves are a form of electromagnetic radiation. Therefore, they strictly obey the absolute speed limit of light. If we somehow detected a hyper-advanced, peaceful civilization on the exact opposite side of the Milky Way, and we transmitted a simple, highly localized, focused radio burst saying, "Hello, we are here," that signal would take 100,000 years to arrive at their receivers. If they were listening, if they managed to catch the incredibly faint signal amidst the background radiation of the galaxy, if they decoded our primitive language, and if they immediately fired a response back to our exact coordinates without wasting a single second, we would have to wait another 100,000 years for the reply to reach Earth. 200,000 years for a single exchange of greetings. 200,000 years ago, anatomically modern humans were just beginning to use rudimentary stone tools in the savannas of Africa. We had not yet mastered fire. We had not invented agriculture, language, or the concept of the wheel. We were hunted by apex predators. By the time an alien reply reaches Earth, the human civilization that sent the original greeting will be completely unrecognizable. We will have evolved into a new species entirely, transcended biology, or, far more likely based on the Fermi paradox, gone completely extinct, wiping ourselves out through war, resource depletion, or cosmic accident. Even if the galaxy is teeming with millions of vibrant, intelligent civilizations, physics enforces a strict, permanent quarantine. Everyone is screaming into the void at the exact same time, but because of the unyielding speed of light, no one will ever hear the answer in time. Number 6. You are always looking into the past. We live our lives assuming the present moment is a universal constant. You look across the room, and you implicitly believe you are seeing the objects, the walls, and the people in front of you exactly as they exist right now, in this exact nanosecond. Human intuition relies on the concept of a shared now. Physics ruthlessly dictates otherwise. Because light takes time to travel from an object to your retina, you never see anything as it is. You only, ever, see it as it was. Look up at the moon. It is the closest celestial body to our planet. Yet, you are seeing a 1.3-second-old projection. If the moon were to suddenly crack in half, you would stare at an intact, perfect sphere for 1.3 seconds before reality updated. Look at the sun. It dictates all life on Earth. But you are seeing an 8-minute and 20-second-old ghost. If the sun vanished instantly, winking out of existence due to some impossible cosmic phenomenon, Earth would be completely fine for over 8 minutes. We would continue to orbit an empty, dead patch of space, happily bathed in warm, entirely non-existent light, for 8 minutes and 20 seconds before the gravitational tether snapped and the eternal darkness hit. Scale this unnerving reality up, and the concept of the universe fractures completely. Find the Andromeda Galaxy in the northern hemisphere on a clear night. It appears as a faint, fuzzy smudge against the blackness. It is our closest major galactic neighbor, a sprawling spiral of 1 trillion stars hurtling toward us. The light striking your optic nerve from Andromeda tonight began its journey 2.5 million years ago. It was emitted when early hominids like Homo habilis were just learning to walk upright and use tools. As human evolution progressed, as ice ages froze the planet and receded, as empires rose and cities burned to ash, that light silently crossed the immense void between galaxies. Now does not exist. It is a local evolutionary illusion designed to keep our brains from short-circuiting. The further you look into the sky, the deeper into the past you fall. You are permanently disconnected from the current state of the universe, trapped in a sensory delay that cannot be bypassed. Number 5. The Alcubierre warp drive illusion. Faced with the crushing reality of the speed of light, human physicists naturally look for a loophole. We refuse to be caged, so we turn to mathematics to pick the lock. In 1994, a theoretical physicist named Miguel Alcubierre published a paper that seemed to offer salvation. He proved that faster-than-light travel is entirely mathematically permitted by Einstein's theory of general relativity. The trick is that you don't push a ship faster than light through space. That is illegal. Instead, you manipulate space itself. You compress the fabric of space-time in front of the ship and rapidly expand it behind the ship. The spacecraft sits completely stationary inside a protective bubble, a warp bubble. It doesn't move. Space moves around it, allowing the bubble to surf a wave of distorted reality faster than a photon can fly. The math works perfectly. The physics are entirely sound. The universe, on paper, allows it. We finally had the blueprint for the stars. Then came the energy calculations. To bend the very fabric of space-time around a modest-sized vessel, you need an incomprehensible amount of energy. But you don't just need normal energy, you need negative energy. Specifically, you need an amount of exotic matter, matter with a negative mass, equivalent to the total mass of the planet Jupiter. Negative mass is a theoretical concept. It has never been observed in nature. It completely defies the standard model of physics. It likely does not exist anywhere in our universe. And even if it did exist, harvesting a Jupiter-sized sphere of it, stabilizing it, and integrating it into a spacecraft engine is a functional, absolute impossibility for any biological species. The universe is endlessly cruel. It dangles the keys to the galaxy right in front of our faces. It provides the exact, flawless mathematical blueprint for our escape, and then it categorically refuses to stock the building materials required to actually construct it. It is a calculated, mocking dead end. Number 4. The infinite mass problem. So, forget warp drives. Forget exotic matter and space-time manipulation. What if we just rely on brute, unadulterated force? What if we build the most powerful conventional engine ever conceived, harnessing antimatter annihilation, nuclear fusion, or even black hole accretion disks, and just strap it to a heavily shielded ship, accelerating continuously until we hit 99% the speed of light? Einstein's theory of special relativity introduces a devastating mechanical penalty for extreme velocity. It is a cosmic speed bump designed to break your ship. As an object moves faster through space, its kinetic energy increases, and because energy and mass are interchangeable, E equals mc squared, the object's mass actually increases relative to a stationary observer. At normal terrestrial speeds, driving a car, flying a fighter jet, even launching a rocket to Mars, this mass increase is so microscopic it goes completely unnoticed. But relativity is non-linear. Push a spacecraft to 90% the speed of light, and its mass more than doubles. It becomes sluggish, heavy. Push the engines harder, fighting for 99% the speed of light, and the ship suddenly becomes 7 times heavier than when it launched. The engines must burn exponentially more fuel just to maintain the same rate of acceleration. Hit 99.9%, and the mass multiplies by 22. The closer you get to the absolute limit, the heavier the ship becomes. The heavier the ship becomes, the more energy is required to accelerate it even a microscopic fraction of a millimeter per second faster. It is an asymptotic nightmare. If a physical object with mass were to actually attempt to reach exactly 100% the speed of light, its mass would become infinite. To move an infinite mass, you need an infinite amount of energy. You would need more energy than exists in every star, every quasar, and every black hole in the entire cosmos combined, just to push a single bolt of your ship over the line. It is not an engineering flaw that we can solve with better fuel. It is a terrifying wall of pure math. The universe actively piles crushing infinite weight onto your ship to guarantee you never, ever break its limit. Number 3. The time dilation trap. Let us assume, for the sake of argument, that we somehow solve the infinite energy crisis. Assume we accept the mass penalty, build an indestructible near-light-speed ship, and launch a courageous crew toward Kepler 186f, a tantalizing Earth-sized exoplanet located 500 light-years away in the constellation Cygnus. Relativity demands a toll for cheating the vastness of space. Time is not a static background ticking away constantly for everyone. Time is deeply intertwined with space, and it is entirely relative. The faster you move through space, the slower you move through time relative to a stationary observer. This is called time dilation, and it is the ultimate psychological horror of interstellar travel. For the crew moving at 99.9999% the speed of light, the journey to Kepler 186f feels incredibly short. Time dilation radically compresses their biological experience of the voyage. They age only a few months during transit. They read a few books. They perform routine maintenance on the ship's reactor. They watch movies, sleep, and wake up. They arrive at the new world young, healthy, and ready to colonize. But while they experienced a few months of subjective time, outside their reinforced windows, the universe ticked on at its normal rate. On Earth, 500 years have passed. When the ship finally decelerates and fires its retro rockets into the atmosphere of Kepler 186f, the crew is instantly, irreversibly orphaned. Everyone they ever knew, loved, or hated is dead. Their parents, their children, their friends are long forgotten dust. The governments that funded their multi-trillion-dollar mission have likely collapsed into the pages of ancient history. Human culture has evolved into something entirely alien, speaking languages the crew cannot understand, or worse, humanity has wiped itself out entirely, leaving the Earth a radioactive cinder. The crew arrives perfectly intact, their bodies preserved by velocity, but they are completely severed from their history. Interstellar travel is not just about moving through space. It requires you to sacrifice your reality. You can cross the distance, but the universe forces you to leave your entire timeline behind. You become a ghost of the past haunting the future. Number 2. The expanding wall we can never break. The distances are vast. The speed limit is absolute. Time is a weapon used against us. But the universe has a final, active mechanism to ensure our total isolation. It is not just keeping us contained, it is actively pulling the floor out from under us. In the 1920s, astronomer Edwin Hubble made a discovery that shattered our understanding of reality. By observing the redshift of distant galaxies, he realized that the universe is not static. It is expanding. The fabric of space itself is stretching in all directions simultaneously. Decades later, astronomers realized this expansion isn't just constant, it is accelerating, driven by a mysterious, undetectable force we call dark energy. The further away a galaxy is from us, the more fabric of space there is between us. Because all of that space is stretching at the same time, distant galaxies appear to be moving away from us at daunting, escalating speeds. At a distance of approximately 14.5 billion light-years from Earth, the cumulative, compounding stretching of space is so extreme that the galaxies positioned there are receding from us faster than the speed of light. They aren't physically moving through space faster than light. That violates Einstein's laws. The space between us and them is growing too fast for light to ever cross it. This creates what cosmologists call the cosmic event horizon. It is a hard, physical, chilling boundary. No engine, no warp drive, no laser beam, and no radio signal can ever cross that gap. Any galaxy beyond that line is fundamentally erased from our future. We can see them now because the light they emitted billions of years ago is just reaching us. But the light they emit today will never arrive. And because the expansion of the universe is constantly accelerating, that horizon is constantly drawing closer to us. It is tightening the noose. Every single second, more and more of the universe crosses that threshold. Hundreds of billions of galaxies, filled with countless stars, planets, and potential civilizations, have already slipped over the edge into the unreachable dark. They are gone forever. The territory available to us, the portion of the universe we can theoretically interact with, is actively and aggressively shrinking. We are stranded on an island, and the tide is permanently rolling in. Number 1. We live inside a bubble we can never escape. Astronomers meticulously measure and map the observable universe. It is a staggeringly colossal sphere centered precisely on Earth, with a radius of approximately 46.5 billion light-years in every direction. It contains absolutely everything we can currently see or measure: every quasar, every supermassive black hole, every galaxy cluster, and every faint trace of the cosmic microwave background radiation left over from the dawn of time. This sphere represents the absolute maximum distance that light has had time to travel to reach our telescopes since the Big Bang occurred 13.8 billion years ago. It feels infinite. It feels like everything. But cosmic inflation theory dictates a much darker reality. In the first incomprehensible fraction of a second after the universe's violent birth, space expanded exponentially, moving far faster than light. Because of this titanic initial burst of inflation, the mathematical calculations indicate that the actual physical universe is staggeringly larger than the portion we can see. The leading models suggest the true universe is at least 10 to the 23rd power times larger than our observable sphere. Run those numbers in your head. What we see, the billions of galaxies that make us feel so incredibly small, is literally nothing. It is a microscopic speck of dust floating in an ocean we cannot perceive. The overwhelming, crushing majority of reality exists entirely outside our view. Trillions upon trillions of other galaxies, unfathomable cosmic structures stretching across infinite dark, and entirely different physical phenomena are out there right now. But because of the finite, unbreakable speed of light, and the relentless, accelerating expansion of space driven by dark energy, absolutely no signal from those regions will ever reach our telescopes. The light will never arrive. No human ship, no matter how advanced, will ever cross the boundary to see what is out there. Physics has locked the heavy iron door of our reality and thrown away the key into the void. We are not just trapped on a pale blue dot. We are not just trapped in a solar system. We are permanently, inescapably sealed inside a finite information bubble, completely and utterly blind to the true scale of the cosmos. The universe is infinite. It is vast, majestic, and terrifying. And by the fundamental laws of nature, we are simply not allowed to see it.